United States Air Force Aviation Information. There are 6 basic components of a fixed-wing aircraft: wings, fuselage, tail assembly, landing gear, power plant, and flight controls and control surfaces. The wings are the primary airfoils of the plane. An airfoil is anything designed to produce lift when it moves through the air. The leading edge of an airfoil is thicker and rounder than the trailing edge, and the top surface of the airfoil has a greater curve than the bottom. The result is that air flows more quickly over the top of the wing, and the greater air pressure beneath pushes the wing and thus the plane upwards. The wings of the plane connect to either side of the fuselage. Planes are designated as high, mid, and low wing depending on where the wings are attached. The wings themselves are described as either cantilever or semi-cantilever. A cantilever wing has sufficient internal support structures to keep it steady in its location. A semi-cantilever wing, on the other hand, requires additional external support structures. The trailing edge of a wing typically has 2 control surfaces attached by means of a hinge. Flaps run from the fuselage to the middle of the wing, and ailerons run from the middle of the wing to the tip. By raising and lowering the ailerons, the pilot can roll the plane. The plane will roll when the ailerons are pointed in opposite directions. When the plane is cruising, however, these control surfaces are aligned with the rest of the wing. During takeoff and landing, both surfaces are extended, which increases the lift. This principle does not apply to aircraft that do not utilize flaps or ailerons for lift or control. The distance from one wingtip to the other is the wingspan, and the distance from the leading edge to the trailing edge is called the chord. The chord line runs through the wing from leading edge to trailing edge and divides the wing into upper and lower surfaces. The mean chamber line runs along the inside of the wing such that the parts of the wing above and below it are equal in thickness. The chamber is the curvature of the airfoil. If an airfoil is heavily curved, it has a high camber. The thickness of a wing is measured at its greatest point. The shape of the wings when viewed from overhead is known as the planform. When the wings are not attached parallel to the horizontal plane, the angle they make with the horizontal plane is called the dihedral angle. A positive dihedral wing angle, wings angling above the horizontal plane, keeps the plane stable when it rolls, as it will encourage the plane to return to its original position. This does diminish the maneuverability of the plane, which is why the wings of fighter jets are usually horizontal or even pointed slightly downwards, anhedral. The shape of the wings has a major influence on the handling, maneuverability, and speed of the plane. Today's planes and aircraft generally have a straight, sweep, or delta shape. Straight wings may be rectangular, elliptical, or rounded, or tapered. They are commonly found on sailplanes, gliders, and other low-speed aircraft. A swept wing can help provide better handling at high speeds, but makes the plane slightly less stable at low speeds. Since most modern aircraft are designed to operate at high speeds, this is the most commonly used wing style, the swept wing. Swept wings may also decrease drag and delay critical Mach. Wings may be swept forward or back, though forward swept wings are rarely seen. In general, a higher angle of sweep is used for planes that are meant to travel faster and be more maneuverable. However, more extreme sweeps require much greater speed for takeoff and landing. Then there's the delta wing. The delta wing shape is triangular so that the leading edge of the wing has a high sweep angle, while the trailing edge is mostly, if not completely, straight. A delta shape enables the plane to travel, but also requires very high takeoff and landing speeds. Many of the earliest supersonic aircraft used the delta wing shape, as did space shuttles. So the delta wing, again, looks more like a triangle, or two isosceles triangles on either side, or, well, two right triangles on either side. The swept wing has wings that come out and back, and then a normal wing is just a straight wing that goes runs perpendicular to the fuselage. Fuselage. The fuselage is the main body of the airplane. The basic features of the fuselage are the cockpit, cabin, cargo area, and attachment points for external components like the wings and landing gear. Some planes designed for specific purposes may not have all of these components. For instance, a fighter jet will not have a cabin for passengers or a cargo area, since it needs to be light and maneuverable. The fuselage may be described as either truss or monocoque, depending on whether its strength is created by triangular arrangements of steel or aluminum tubing, or by bulkheads, stringers, and formers. A stringer is a support structure that runs the length of the fuselage, while a former runs perpendicular. Tail assembly. The tail assembly, or empennage, includes the vertical and horizontal stabilizers, elevators, rudders, and trim tabs. The stabilizers are fixed, non-adjustable surfaces that extend from the back end of the fuselage. The elevators are positioned along the trailing edges of the horizontal stabilizers. The pilot can move them to raise or lower the nose of the plane. The rudders are connected to the trailing edge of the vertical stabilizer and are used to move the nose of the plane to the left or to the right, typically in combination with the aileron. The trim tabs are movable surfaces that extend off the trailing edges of the rudder, elevators, and ailerons, and are used to make smaller adjustments. Landing gear. The landing gear usually consists of 3 sets of wheels used for takeoffs and landings, though some planes have special non-wheel landing gear for landing on snow or water. Landing gear is commonly retractable, meaning that it is pulled up inside the plane during flight to reduce drag. And some planes, even hydroplanes, have landing gear, retractable landing gear, so it can land on flat surfaces or water. In a typical arrangement, wheel sets are positioned either under each wing or on the sides of the fuselage, with the third wheel set being under the nose or the tail. The most common arrangement on modern aircraft is the tricycle arrangement, which has the third wheel set under the nose, but having the third wheel set under the tail is still known as the conventional arrangement. Whether located under the tail or the nose of the plane, the third wheel will typically be able to rotate so that the plane can turn while traveling on the ground. The addition of extra wheels to each set allows the plane to handle a greater weight. Power plant. In aviation, the power plant is the part of the plane that supplies thrust. A jet engine operates by compressing the air that comes in the front, burning it along with fuel, and then blasting it out the back. There are different methods for compressing the air, but most jet engines do so by slowing it down with a set of small rotating blades. This greatly increases the air pressure at the front of the engine. The compressed air is then forced into a different section where it is mixed with fuel and burned. As it then expands, it is pushed at great force through a series of turbines, the turning of which moves the compressor blades at the front of the engine, supplying both power and air. The exhausted air then passes out the back of the engine, which propels the plane forward. Some jet engines have afterburners, which feed extra fuel into the area between the turbines and the rear exhaust, increasing forward thrust. In a propeller plane, on the other hand, the power plant is the propellers and the engine. The propellers have tilted blades which push air backwards and thereby push the plane forward. There are two types of propeller, fixed pitch or variable pitch. The blade angle of a fixed pitch propeller cannot be adjusted by the pilot. Variable pitch propellers allow the pilot, usually indirectly via the plane's control systems, to adjust the pitch of the propeller blades to alter the amount of thrust being generated. Some variable pitch propellers are designed to operate only at a single rotational speed, allowing the engine to be much simpler and more efficient, so the amount of thrust is controlled entirely by the pitch of the blade. These are known as constant speed propellers. The engines of a propeller plane turn the crankshafts, which turn the propellers. The engines also are responsible for powering the plane's electrical system. The location of the engines on a propeller plane may vary. Single-engine planes typically have their engines in front of the fuselage, while multi-engine planes usually have their engines underneath the wings. Some multi-engine planes have engines in both locations. Flight envelope. During flight, there are 4 forces a pilot must manage: lift, weight, thrust, and drag. These forces act downward, weight, upward, lift, forward, thrust, and backward, drag. These forces are fundamental for understanding both how flight works and the range of permissible flight conditions aircraft can tolerate at any given point in time. A flight envelope is a graphical representation that helps pilots and aircraft designers operate and calculate the limits of an aircraft within various flight parameters to ensure safe and efficient flight. Weight. The weight of a plane is the primary force that must be overcome for flight to take place. The force of gravity on a given object is the same regardless of orientation, though it varies slightly with large changes in altitude. Aviation experts distinguish between different types of weight. The basic weight includes the aircraft and any internal or external equipment that will remain a part of the plane during flight. The operating weight is the basic weight plus the crew and any other non-expendable items not included in the basic weight. The gross weight is the total weight of the aircraft and all contents at any given time. The weight of the airplane when it has no usable fuel is called the zero fuel weight. Lift. In order to overcome gravity, the plane must generate lift. Lift is the upward force of air pressure on the aircraft, primarily the wings, that allow it to achieve and maintain altitude. In order to generate lift, the plane typically must be traveling forward at considerable speed. If the wing tilts too far back, the airflow may stop over the wing's upper surface, which will result in a rapid loss of altitude and often control of the plane. This is known as a stall, and it may be avoided by decreasing the angle of attack so that normal airflow over the top of the wing is not interrupted. Thrust. The speed required for generating lift is provided by the aircraft's thrust. It ensures that the aircraft is able to continue moving forward at sufficient speed to generate lift. As was discussed in the previous section, thrust is generated by the power plant of the aircraft, usually one or more jet engines or propellers. Drag. An aircraft's thrust is countered by drag, the resistance to forward movement provided by the air that the aircraft is traveling through. At anything above normal walking or running speed, air resistance is a noticeable hindrance to motion, and it only increases as airspeed goes up. The primary implication of this has on aircraft is that the faster the aircraft goes, the more thrust is required just to overcome the drag and maintain a constant speed. Drag is usually categorized in 2 basic ways: parasite drag and induced drag. Parasite drag is the combined value of several types of drag like form, skin friction, and interference, which are all non-lift producing components. Induced drag, on the other hand, is drag that results from the wings generating lift. Part of the process of generating lift involves the wings redirecting the oncoming air downward. Think of Sir Isaac Newton's third law, and this causes additional drag. Atmospheric conditions. The flight envelope is significantly affected by the atmospheric conditions, primarily the density of the surrounding air and the speed and direction of any wind. The density is in turn determined by the temperature, pressure, and humidity of the air. Lower temperatures, higher pressures, and lower humidity are all associated with higher density air, and denser air will produce greater lift, but will also produce more drag. Air pressure is most closely associated with altitude. In general, pressure decreases with altitude. So as you go higher up, the pressure of the surrounding air decreases. With regard to wind, flying into the wind or headwind has a similar type of impact to flying in denser air, though of much greater magnitude. In a headwind, the aircraft will have a higher speed relative to the surrounding air, which means it will experience greater drag and lift forces. Similarly, if the aircraft is flying in the same direction as the wind, which is a tailwind, it will have a lower speed relative to the surrounding air and will experience reduced drag and lift. And then there are some flight concepts and terminology, such as flight attitude, flight controls, primary flight controls, secondary flight controls, flight maneuvers, helicopters and helicopter controls, and then airport information.